Today we are going to start these Leetcode questions of part 2, right? So the questions we have in the first part we have already seen that this 797 question, right? We have started with the first approach, that is recursion, right? In which we have seen how we have moved to a directed cyclic graph DAZ of n nodes from 0 to n minus 1, how we have made our all possible paths, right? So using the recursive function. So let's recap, right? So what we have did here, we have started from a starting node, right? And then we have possibilities of moving either this way, of moving to the end of the target if this is our target node, right? Or either we will move to this way, right? So there is two possibilities, right, in which we will have our nodes, right, to move with the possible paths. So in which what we have seen that we have taken target, graph and result. Why we are talking about, again we are recapping, because we are going to use the DP in the another approach, right? Here you can see dynamic programming, in which we will see that we are using only extra memory part, right? You can see. Okay, so how we will use that? Okay, so previously in the backtracking we have taken target, graph, result, in which we have taken a recursive function. These were our recursive function, and this recursive function we are calling each time here. Give me here, we are calling here, right? So what we have did here, this is our main function in which we are passing all the graph, right? So this we are passing what first what you can say, source node, that is node 0, and the path, right? And we will get all the path, right? So if we'll pass this path, if we'll pass this path in the recursive function, right? So he will calculate uh, first this path, and then he will add another this path on the what path, right? This path, and this, what is this path? This is the list of integer, right? So we will get the path here. So this is the path, right? So this is path, right? And this path, if we'll say that this is the path as a list, you can say this is a list, right? So it will store all the node, right? We will start how we will add. We'll first check, it will go to the recursive, right? This is 0 if this is the node 0, and this is the path, right? So it will come here first, current node equal to target, right? So what will happen, we will add this path, we have initialized this path, and then with this we are adding this path, right? We are not passing anything. That means we are at the end. If we are not at the end, right? So we have to add this one, right? So in this we will traverse all the nodes, right? All the neighbor nodes. So we'll get the next node, and then we will add the next node, right? So after the 0 node, whatever the node, like let's see, this is node 1. So after the this node first, right, we have a next node is what, 1. So we will store here. Next, what we will do, what we are doing, we are adding we are doing backtrack, right? Means we are calling again. After the node 1, we will check another node, right? Whichever the node is there, let's see, suppose there is 3, right? We will put the 3 here, correct? And after that, what we will do, we will remove the path dot remove last. We will remove the last one, because we do not need to go to the last node, right? We will not, that is not required. So whatever the node will come here, that we will remove, right? So this will our path 1, right? And this path we will add into where, the result. So you can say, you can add on the result. We are adding somewhere this one, right? We are adding here, okay? And we have initialized that path, right? And that we will the final we will return the result, right? So result is we are adding the result, right? And at the when we will come to the last, right, here at this position here, then we will add this path to result. So this will come to the result, and result is what, this is the list of multiple paths, right? So I am adding one path 1 and path 2, like this, correct? This is path, and this is path. So it will actually is what, this is the list of list, this is a list, and this is a list, two list we are passing, correct? And this is our result. This is our result. So this is our data structure that I am talking about, right? But what is that? We are doing backtracking. So we have created first the backtrack function, and this backtrack function is calling at the line of what line here 31, right? Here, correct? And that's all. Now we come to the dynamic programming, right? DP, in which we will take the first memo as a uh, temporary. We'll store all the result here, you can say. Okay, so we'll take memo here, and then what will happen, we'll call here is our main function, right? Main function in which we will passing target, right? So this function will initialize the target, graph, and the memo. Now memo we have initialized here as a hash map, right? And then we will pass the first node, what all path to target. And this all path to target is what our you can say a function, right? DB function. This will first check if that is already what at the we have already calculated the subtask, right? Means node, next node is we have already calculated, right? Current node. Then we return from the memo, we will get the return from the memo. If that is not the case, right, means we are if we are at target, means we are at the end of the node, right? Then we will do what, we will add all the path on the result, right? We will, that we are talking just last, right? Now finally we will return the result if we are at the last. If we are not at the last node, means we are the middle, right? Then what we will do, we will calculate all the next node. So only these three steps will be there, right? So we will traverse all the nodes, right? We will all the next node, then we will get the next node path, right? Then we will add, then on the new path we will add the next current node, we'll add the current node, right? Then we will add all the path, and finally we will add the result. And after that we will add on to the memo, right? We put on the map, right? And then finally we will return the result. So in this way we will do our dynamic programming, right? Let's recap. So if we'll talk about this function, this is our main function. Okay, this is our main function. So in the main function, what we will do, we will initialize our target, graph, and memo. And this is our function. We'll take another function, right? And this function will take our initial index, initial node, you can say node source node 0. And this function will be here, right? So we have to understand that this is our current node, that we are passing 0, that is our current node. So if we will check memo contains key, right, that is what current node, then we will return from the memo if memo is already containing the current node value, right? So we will return from the memo here, like memo dot get current node. And then finally we will initialize our result, and this result should be added all the path. So you can see here we are at the line number 16, right? We are adding all the path. So this is the case. Line number 13 is the base of current node is equal to target node, is what we are checking at the last node, right? We're not at the source, we are at the target. So we have traversed all the next nodes, okay, all the nodes you can say. And we have the path. So path we have to add target, then we have to add result, we will add the path, and finally we will return the result. And here what we are doing, we will iterating the neighbors, right? And we will iterate through the path through each neighbors. So for that what we do, this dot graph, we will pass the current node, then we will get the next node. And now for all the path we have to pass this all path to target. Previously we are passing 0, right? Now we will pass all the next node, then we will get the path. And all the paths we have to add here where on the new path. So first we will add to the new path dot add all path, and finally we'll add to the result path, right? We'll add onto the result all the path, and finally we'll put the current and the current node and the result, and we will return the result. If we have not calculated, means we are iterating to the next node, right? And if we'll have, then we will return directly from the memo. If not that the case, if we are not we have, means we are iterating the next node, so that we are putting here, and we are, if we have already calculated, that we are returning from here memo to get node, right? So that's all we have. So let me know if you need any help. Thank you so much. Thank you so much, guys. Please help me in growing this channel, and by liking and subscribing. You can share with your friend too. Thank you so much.